Namaskar. Welcome in this lecture series of software engineering. This is Dr. Keswani, professor in computer science and engineering in Suresh Gyan Vihar University, Jaipur. In today's lecture, we will discuss about coding and its various standards. And uh, our today's lecture is related to the software testing techniques and strategies. This is the second lecture in this topic. The learning object are of this lecture that through this lecture you will learn various concepts of software testing and in-depth knowledge about software testing process and planning. The learning expected learning outcomes are that after the completion of this lecture, you will be able to understand about various software testing methods and testing process. You should aware of the importance of you will aware of the importance of test cases and you differentiate various methods of software testing. So I hope that this session will provide you the insight about the understanding about various software testing methods and software process and how to conduct the software testing. These are some contents of this lecture. First, we will discuss about the software testing process. Then we will discuss about static analysis. Then we will discuss about dynamic analysis and software test design. Software, let us discuss about the software testing process. And this table depicts what? This table depicts about testing process states, where there are several stages of software testing process, and we can say that there are basically 5 stages of software testing. uh, First is component testing, second is integration testing, third is user testing, fourth is verification, and fifth is validation. And all types of testings are the part of these 5 stages. Except for small programs, systems should not be tested as a single unit. Large systems are built out of subsystems, which are built out of modules that are composed of procedures and functions. The testing process should therefore uh, proceed of stages where testing is carried out incrementally in conjunction with software implementation. So this is a clear-cut illustration that this table provides you the in-depth story about the testing stages. Unit testing and module testing comes under the component testing part, and system testing and system testings are the part of integration testing. Then acceptance testing is related to the user testing, and there are 2 processes: verification and validation. Verification process is related to the white box testing techniques, consist of white box testing techniques, and in this type of testing methodology, tests that are derived from knowledge of the program's structure and implementation are implemented here. And in the validation, which is a product oriented thing, black box testing techniques we will use in the software testing process. As defects are discovered at any one stage, they require a program modification to correct them, and this may require other stages in the testing process to be repeated. Error in program component, say, may come to light at a later stage of the testing process, and the process is therefore an iterative sort of thing with information being feedback from later stages to earlier part of the process. So you can say that software is a testing is a continuous process, which you can say it is a iterative process, and it is in the SDLC, in the software development life cycle. This is the only process which is a very uh, costly process. This is the process which is very time consuming process, and this is the process which is very much important process, because through the testing process you can ensure the quality of your software system. So what kind of illustration, what kind of iteration is there? So this uh, process, software testing process, in this illustration provides the idea about iteration of the software testing process. There is some iteration like unit testing. After the conduction of unit testing, you can conduct the module testing, and module testing and unit testing are the part of component testing. Then system testing and system testing are the part of integration testing. Then we will deliver it to the user for acceptance testing. And if the user is not satisfied, then after the acceptance testing, what will happen? We will again doing the system testing. We will again doing the system subsystem testing. We will again doing the module testing, and we have to do again the unit testing. So we can say it is a iterative process. Software testing process is a iterative process, because it repeated again and again. It will repeat again and again till the user gets satisfied. Okay, so user training is user testing is another part, is one part. Component testing is second part, and integration testing is the third part. So we can say that iterative software testing process consists of three types of main testing. First is related to the component testing, second is related for the integration related issues, and third is related to the user satisfaction. Okay, now come to the first thing, that is unit testing. What is unit testing? So iterative testing process consists of unit testing, module testing, subsystem testing, system testing, acceptance testing. All I elaborated, all I discussed in the uh, illustration. Uh, Now come to the now all the uh, all types of testing processes we will discuss one by one. We have a brief discussion about this. Uh, what is unit testing? Unit testing is code oriented testing. Individual components are tested to ensure that they operate correctly, and each component is tested independently without other system components. So we can say that unit testing is the important part, because complex problem software is a solution of complex problem, and how to provide a solution to the complex problem, you should divide the complex problem, you should break out the complex problem in many subdivisions, and these units or subdivisions to be tested, okay, uh, individually. Second is module testing. A module is a collection of dependent components such as object, class, an abstract data type, or some looser collection of procedures and functions. So it is a basically collection of dependent components, a module. So a module encapsulates related components, and it can be tested without other system modules. So testing of individual module is called as module testing. Okay, now come to the next type of testing, that is subsystem testing, and this phase involves testing collections of modules and uh, which have been integrated into subsystems, and it is a design oriented testing, and it also known as integration testing. So you can say that subsystem testing is a type of integration testing. Subsystems may be independently designed and implemented, and the most common problem which arise in large software systems are subsystems interface mismatches. So it is a big problem when we are it is a very common problem when we are making we are developing a large software system. Subsystems integration interface related problem is a big problem, and the subsystems test processes should uh, concentrate on the detection of interface errors by rigorous exercising these interfaces. So, subsystem testing, you can say it is a interface. It is due to the interface mismatch, and it should be resolved because somewhere it is related to the integration of modules. Okay, modules of all of the system. Second is system. Next testing type is system testing. The subsystems are integrated to make up the entire system. So as we know that all the small parts or modules or units make a whole system. Okay, so when it is necessary to integrate all the subsystems to make a system. Okay, so the subsystems are integrated to make up the entire system, and the testing process is concerned with finding errors that result from anticipated interactions between subsystems and system components, and it is also concerned with validating that the system meets its functional and non-functional requirements. So, uh, system testing is not only concerned with the uh, integration of all the system components, it is related to the fulfillment of functional and non-functional requirements of the system. The next one is acceptance testing. User why we are making the why we are developing a software. We are developing a software for the user, for the end user, for our client. Okay, so what is needed? Acceptance testing is needed, whether the user is satisfied with our project with our product or not. Okay, so this is the final stage in the testing process, and before the system is accepted for operational use, the system is tested with data supplied by the system clients rather than simulated testing. Okay, so simulated data. So when we have a satisfied user, uh, um, uh, we can implement the final product. Okay, we have to install the final product. So acceptance testing may reveal errors and omissions in the system requirement definitions, which is a user oriented thing, and because the real data exercises the system is different way from the test data. Acceptance testing may also reveal requirement problems where the system facilitates do not really meet the user's needs, that is functional needs, or the system performance, that is non-functional needs, is acceptable unacceptable. Okay, so basically acceptance testing is concerned with the functional and non-functional needs, whether this proposed whether the developed system software uh, deliver the fulfills the uh, functional and non-functional need of the client. Okay, it is to be tested in the acceptance testing. I hope you understand all these concepts. Next is static analysis. uh, Static analysis seeks to detect errors without direct execution of the test object. So, static analysis techniques do not necessitate to execution of the software. The activities, there are several activities in the static analysis. You can see in the screen, the code inspection is the first activity, complexity analysis is the second activity, structural analysis is the third activity, and data flow analysis is the fourth activity. So there are several activities done to performing together and make the static analysis completed. First, we will discuss about the code inspection. Uh, Code inspection is a useful technique for localizing design and implementation errors. When we before implement the code, we have to identify the errors. Okay, so code inspection is very useful to identify errors present in our code. Many errors prove easy to find if the author would only read the program carefully. Okay, so if you are a programmer or you are a coder, you should uh, read your program at least as at read your program carefully. Okay, at least once. So the idea behind code inspection is to have the author of a program discuss it step by step with other software engineers, and the moderator notes every detected error, and the inspection continues. So the task of inspection team is to detect, not to correct errors. So what is the purpose of code inspection? To detect errors, not to correct the errors. Okay, correction is the part of uh, corrections to be done at the programmer's end. But the what is the purpose of code inspection? To detect errors and submit it to the moderator. Okay, and if moderator wants to uh, change in the software, then he will suggest to the programmer about changes. Only on completion of the inspection do the designer or the implementer begin their correction works. Okay, so code inspection is a important thing, which is the part of static analysis, which is you can say the first activity of static analysis. The second activity of static analysis is the complexity analysis. So the goal of complexity analysis is to establish matrices for the complexity of the program, and these matrices includes complexity measures for modules, testing depth for loops, and length of procedures and modules, import and use frequencies for modules, and the complexity of interfaces for procedures and methods. So complexity analysis is the second part of static analysis. It is the second activity of static analysis, and through this complexity analysis, we can check, we can establish the matrices for the complexity of the program. Complexity means difficulty to evaluate objectively. A program that a programmer perceived as simple might be viewed as complex by someone else. One thing is complex for me, but the same thing is maybe not complex to other. So we should in this activity we should uh, get some matrices. We should establish some matrices, some parameters, some measurements for module size of module, nesting depth of loops, and length of procedures in modules, and import and use frequencies of for modules, and complexity of interfaces of for procedures and methods. So uh, uh, when we access when we uh, measure the complexity of the system, we can easily find out the error in the system. Okay, so what is suggested? It is suggested after the complexity analysis. It is suggested to reduce the uh, uh, complexity at what level. Okay, so you have to uh, you have to measure the complexity of the problem. The next one is structured analysis. So the goal of structured analysis is to uncover structural anomalies of a test object. Okay, so structured analysis, you can make a plan, you can make a uh, proposal how to done the analysis, which is very important. And next and last is data flow analysis. Data flow of data is very important in the within the software. When you are going to establish, when you are going to make a design a software, it is very much important that you should uh, make proper flow. You should depict proper flow of the data. So data flow analysis is also an important thing. Data flow analysis is intended to help discover the data flow anomalies, and data flow analysis provides information about whether a data object has a value before its use and whether a data object is used after an assignment. So data flow analysis applies to both the body of a test object and the interfaces between test object. Okay, so we had discussed about various activities uh, we have to um, conduct when we are conducting the static analysis of the software. Now come to the next thing we will discuss about, the dynamic analysis. And you can say that for dynamic testing, the test objects are executed or simulated, and dynamic analysis is what is generally considered as testing. That is, it involves running the system. Okay, so dynamic testing is an imperative process in the software lifecycle, and for every process, every module, every class, every subsystem, and the overall system must be tested dynamically, which is the purpose of dynamic analysis. Okay, these are the activities you can conduct. You have to conduct in the dynamic when you are conducting the dynamic analysis. The first activity is preparation of the test object for error localization. Second is availability of a test environment. Third activity is selection of appropriate test cases and data. If they are not available, you should make the test cases or generate the test data as which is suitable for the system testing. And then test execution and evaluation. So execution of test cases is important thing, and evaluation of that test is also an important thing. So you have to very cautious uh, about these activities when you are doing the dynamic analysis. The uh, next thing is now we will discuss about the software test design. The design of software test is subject to the same basic engineering principle as the design of software. Good design consists of number of stages that progressively elaborate the design of test from an initial high-level strategy to detailed test procedures. Pressman suggested the software test design stages in 1998. These are some stages. These are the essential stages of when you are you are making the software test, you are designing the software testing. Stages are, first is test. You have to make the test strategy, you have to make the test plan, you have to make the test case design and test procedures also, and then test result, document the test results. So these are the stages that you have to uh, start when you are making the software test designing. So the design of tests has to be driven by the specifications of the software, and at the highest level of means that tests will be designed to verify that the software faithfully implemented the requirements of the functional specification. What is functional specification? It is a document. It is the document which provides the complete specification of the system. There are at lower level test will be designed to verify that items of software implementation, all design decisions made in the design specification and detailed design specification. So there are three things. First is functional specification, second is design specification, and third is detailed design specification. So what is required? It is required to uh, make the software test design, make the strategy at the high level and at the lower level. Lower level, you can consider the design specification document and detailed design specification document, and the higher level you can you should uh, give stress on functional specification document. Okay, the ease with which test can be designed is highly dependent on the design of the software. So the detailed design specification document and functional specification document is the your strategy, testing strategy. It depend on all three design documents. Okay, and it is important to correct testability as a key requirement for any software development. Remember this thing. Now come to the uh, next thing. First, we have to formulate the test strategy. A test strategy is a statement of the overall approach to testing, and identify what levels of testing are to be applied, and the and about the methods, techniques, and tools to be used. So, a test strategy should ideally be organization wide and being applicable to all organizations software development activity. So, a test strategy should be apply based on the design process. The second thing is when you are going to design the software testing, the second stage is test planning. Okay, so the development of test plan is an important thing, and the test plan states what test plan states that what the items to be tested are. Second thing is at what level entry all at what level they will be tested, and thirdly what sequence they are to be tested in, and fourth and lastly how the test strategy will be applied to the testing of each item, and describes the test environment. So this is the uh, test plan related thing. Various types of test plans are there. First is acceptance test plan, second is a system test plan, third is software integration test plan, and last one is uh, unit test plans. So let us discuss about acceptance test plan. Acceptance test plan basically describing the plan for acceptance testing of the software, and this would usually be published as a separate document, but might be published with the system test plan as a single document. So acceptance test plan is a important plan. It is an important document. It is a document which is published separately, because if the acceptance test plan is, because it is related to the user, and developer is the person who has a biased view about regarding his software, his project. So sometimes uh, we have to uh, segregate, we have to publish a separate document which is called as acceptance test plan. Okay, it is a single document. uh, Second thing is a system test plan. So describing the plan for system integration and testing, we have to develop the system test plan, which is the plan for system integration and testing. So, okay, so system test plan is describing the plan for system integration and testing, and this would also usually be published as a separate document, but might be published with the acceptance test plan, because as I earlier said, that uh, uh, the developer's view is the biased view. So he is not uh, accept your planning. So system test plan is a separate plan, and it is a part of software test design. Okay, the third type of test plan is software integration test plan, and it is describing the plan for integration of tested software components. So it is when you are making a soft you are making various components in the software, then describing the plan for integration of the software tested software components is a very important thing. So a planning should be there, and this may form part of the design specification. So you can mention the strategy, the plan in the design specification document about the software integration test plan. Okay, the last one is unit test plan or plans. It describing the plans for testing of individual units of software, because as it name suggests that it is a unit test plan. So describing the plans for testing of individual units of software, and these may from the part of detailed design specification. Okay, so what is the objective? The objective of each test plan is to provide a plan for verification by testing the software. The software produced fulfill the functional or design statements of the appropriate software specification. And in the case of acceptance testing, the system testing is to be done, and this means the functional specification should be provided to the planner. Okay, so the basic aim of such type of planning to reduce the cost of the software. Okay, now come to the next slide. Um, this is the another important part of software testing or quality assurance: test case design. How to conduct the testing? It is a major question. How to test a system, software system? You should have to uh, create. You should uh, create. You should design some test cases. Okay, you should design test cases for acceptance testing. You should design test cases for system testing. You should design test cases for software integration. Okay, and you should design test cases for unit test. So it is cases should be designed in such a way as to uncover quickly and easily as many errors as possible, and they should exercise the program by using the and producing inputs and outputs that are both correct and incorrect. So once the test plan for a level of testing has been written, the next stage of test design is to specify a set of test cases or test paths for each item to be tested at that level. A number of test cases will be identified for each item to be tested at each level of testing, and each test cases will specify how the implementation of a particular requirement or design decisions is to be tested and the criteria for success of the test. So what is the objective of case test design? The objective of the test case design is to test all modules and then the whole system as completely as possible. So by using a reasonable wide range of conditions. So what is the objective of test case design? The purpose of design of test cases to test all the modules and to test the whole system completely. Okay, uh, with all possible conditions of failure. Okay, uh, there are some specifications or you can write in a separate document which is called as test description. So test design are mentioned in the test description document. The first thing is acceptance test specification, which is specifying the test cases for acceptance testing of the software, and this would usually be published as a separate document but might be published with the acceptance test plan. And the secondly, system test specification, which is specifying the test cases for system integration and testing, and it is also a separate test document. The third is software integration and test specification, which is specifying the test cases for each stage of integration of tested software components, and these may form sections of the design specification. Okay, so software integration test specifications are the uh, stage, or you can say it is an activity which is very important. The fourth thing is unit test specification. So it is used to specifying the test cases for testing of individual units of software. Okay, so and these may form the sections of detailed design specification. So it is uh, you can say the unit test specifications are the part of detailed design specification, and it is important to design test cases for both positive testing and the negative testing, because positive testing checks that the software does what it should, and negative testing checks that the software doesn't do what is shouldn't. Okay, the process of designing test cases, including executing them as uh, through experiments, and it will identify bugs before the software has even been built, and it is not uncommon to find more bugs when designing tests than when executing tests. Okay, so it is very important to design various types of test cases. Okay, the now we will come to the next two uh, next another parts of this lecture, the test procedures and the test result documentation. Okay, first we will discuss about test procedures, the final stage of this test design. What is the final stage? Final stage is to implement a set of the test cases as a test procedure. Okay, and what is test procedure? It is specifying the exact process to be followed to conduct each of the test cases, and this is the straightforward process uh, which can be designed the unit of codes from higher level to functional descriptions. Okay, and for each item to be tested at each level of testing, a test procedure will specify the process to be followed in conduction the appropriate test cases. A test procedure cannot leave uh, step or make assumptions. It is not based on assumptions. Okay, it is a real procedure. So testing is a real thing. Testing is can be repeated again and again till we uh, achieve the quality software. Okay, and there are several levels of testing, and each level is important. We had discussed in um, previous lecture also. There are several test stages. Now come to the next and last thing, which is test result documentation. Documentation is always important when you are doing the software development, when you are developing a quality software. So documentation is related to the development of quality software. What uh, is the outcome of testing? How you what is to be mentioned in the test document? These are some basic questions. Why documentation is required? Why testing results should be documented? Because when you are making the test cases, you are ensuring the quality of the software. Okay, so each test execution, the result of the each execution, the result of each testing should be documented along with the test cases, whether it is real, whether it is artificial, or whether it is getting from the manual process. Okay, so you should document, you should make a document of test results in the form of uh, test document. Okay, and it is a valuable, you can say it is a test report is a valuable document. Whenever we get some uh, whenever we find some errors in the software, we can consult such documents, and such type of documents will be helpful in the uh, process to get the information and how to resolve the about how to resolve the errors. Okay, this is all about from my side in today's lecture. uh, this is the time for assessment, self assessment through multiple choice questions. The first question is: organization can have in house inspection, directly involvement of users, and release of beta version are few of them, and it also includes usability, compatibility, user acceptance, etc. is called. The first option is task analysis, second is GUI requirement gathering, third is GUI design and implementation, and last is testing. So the correct answer is testing. Testing is the um process which organization can have in-house, uh, uh, provides a facility to the organization to have in-house inspection and direct involvement in the user, and to provide the beta version also, and it ensures the usability, compatibility, and user acceptance, etc. The second question is: dash is common method of validation, testing, verification and validation both, review, and none of above. The answer, correct answer is testing. Testing is the common method of validation. The third is: in the dash method of testing, the program is executed on some test data and follow traditional patterns of testing. Presence of errors is detected by this method. The first option is static, second is dynamic, third is both, and D for none of above. So in the dynamic method of testing, the program is executed on some test data and follow traditional patterns of testing. Okay, so right answer is D. The next question is: testing through test data is done only in dash method of verification and validation. So there are four options. First is static, second is dynamic, third is both, and fourth is none. So what is the answer? Testing through test data is done only in dynamic method of verification and validation. So the correct answer is B. The fifth is Testing without the use of test data and verification through code reading and code review is only done in dash method of verification and validation. So, testing without the use of test data and verification through code reading and code review is only done in static method of verification and validation. Okay, so the answer is A. In the next question is the fault is, what is fault? The difference between the actual output of the software and the correct output, a condition that causes a system to fail in performing its required function. C. The inability of a system component to perform a required function according to its specifications. Or D. All above. The correct answer is the fault is a condition that causes a system to fail in performing its required function. So the correct answer is B. The seventh question, the dash is the last phase before the final software is delivered. Options are coding, testing, verification, or code review. The correct answer is, what is the correct answer? The testing is the last phase before the final software is delivered. So the option B is correct. In the eighth question, dash has responsibility of detecting any type of error that may be in the software. The options are coding, testing, verification, and code review. What is this? What is the correct answer? Testing has responsibility of detecting any type of error that may be in the software. So the correct answer is B, testing. The ninth question, as testing is the dash activity in software development, it is important that it is to be done efficiently. The options are costliest, time consuming, very fast, or none of above. As I said during the lecture, the testing is the costliest activity. Although it is, but why it is costliest? Because it is time consuming activity. So the answer is A. It is a costliest activity. The last question is dash refers to the response time or the system being installed. A. Loop testing. B. Data flow testing. C. Condition testing. Or D. Performance time testing. So the answer is performance time testing. Performance time testing refers to the response time or the system being installed. So uh, this is about all about assessment work. And if you have any query, please consult with these books. These books uh, will provide you help to find out the answer of your query. And this is all about today's lecture. I hope this lecture provided you a clear cut understanding about the topic that we have chosen for today. And have a good day. Thank you very much.